Okay, Unit 5. Unit 5 is about linear system. Now we have the first part, lesson 11.1. So, solving linear system by graphing. So, the first part, tell number of solutions for each system of two linear equations and state if the system is consistent, inconsistent, dependent, or independent. Okay, the first one, let's look at the first graph. The first graph, we have y-axis and x-axis, right? X-axis, y-axis. So for the x and y coordinate system. Now we have two lines. One is this, another one is this. So this two lines, the linear equation graph, and they intersect at one place, one point. So this point is on both lines. So this point is a solution. So this system have one solution. So we're going to put one solution. Okay, what about consistent? What does consistent mean? Consistent means at least one solution. The system at least have one solution. So yeah, so this system, the first one, yes, there's one solution. So yes, it's consistent. What about the dependent or independent? Independent. So this one is independent. Why? Because independent means exactly one solution. So this one is independent. The two lines, they go through different paths. We only cross each other one time. That's it. So it's independent. They don't depend on each other. Okay, let's look at the second graph. We only have one line look like. But in fact, when we tell you this is a system, that means we have two equations. Even though the two equations may look different, but they are equivalent. That means if you rearrange the equation, these two different equations become exactly the same one. After you simplify, you rearrange the terms. So that means we have two lines overlap each other. So one exactly lay on the other one. So we have so many solutions because they cross each other at infinitely many points, right? So how many solutions? Many solutions. We're going to say infinitely many solutions. Infinitely many solutions. Too many solutions. And so it is consistent. That means at least one solution, right? Consistent. But they are not independent. They are dependent. They lay on each other. They overlap each other. They depend on each other. So they're dependent. Okay, number 3. Number 3, we have two lines. This one and this one. These two lines, they are parallel to each other. They never cross each other. Parallel lines. So they don't cross each other. That means there's no solution. No solution, that means it's inconsistent. Inconsistent. And they are not dependent or independent. So all we need to put is no solution and inconsistent. Okay, number 4. We are going to solve each system of linear equation by graphing. So first, we're going to graph x plus y equal to 3. So this equation is in x and y intercept form. That means we can find the 2 points. One is on the x-axis, another one is on the y-axis. So we connect them together. That's the graph. Okay? So when this kind of equation, both x and y on the same side, on the left, and we have a pure number on the other side, we call this kind of form as a standard x-intercept form, because we can use this equation quickly find out the x-intercept and the y-intercept. I'm going to show you how. Okay, for x-intercept, we are going to get rid of the y term, because any point on the x-axis, for example, this point, the x coordinate is 1, 2, 3, 4, 5. So it's a 5. The y value, the y coordinates is 0. Here's 0. So the y value is always 0. That means when y is 0, that means we get rid of that term, right? So x equal to 3. This system is really simple. We don't even need to solve it, especially for the first one. So x equal to 3. That point is 1, 2, 3 right here. So I'm going to put this point right here. And then I need to figure out the y. The y-intercept. Get rid of the x term. We're going to have y left. So y equal to 3. Right? For the equation, we get rid of the x term. We're going to have y left. So y also equal to 3. So y also equal to 3. 1, 2, 3 right here. And then I connect those 2 points. Makes the line a little longer on both sides. So that's the graph. Okay, the first graph is done. Let me do the second one. Negative x plus y equal to 1. Let's find the x-intercept. So negative x equal to 1. Get rid of the negative by multiply both sides by negative 1. So x equal to negative 1. X equal to negative 1. The point is right here. Yeah, negative 1. So here is 0. Here's the origin. And then this is 1, 2, 3, 4, 5. And here's negative 1, negative 2, negative 3, negative 4. Right? This side is positive. The other side is negative. For the y, this is up is positive. Right? So 1, 2, 3, 4. And go down, this is negative 1, negative 2, negative 3, negative 4. X and y coordinates, right? X and y coordinate plane. Now we're going to figure out the y. The y, the original equation is this. Get rid of the x term. So y equal to 1. Y equal to 1. Y equal to 1. The point is right here, right? This point. Now I'm going to connect these 2 points. Make it a little longer. Both ends make it a little longer. Yeah. So the point, they cross each other. That's the solution, right? This point. Let's go check. This point's x coordinate is 1. The y coordinate is 2, right? So from this point, you go to the x-axis, it's 1. You go to the y-axis, this is 2. So the solution is 1, 2. We use parentheses. And And the first value always x. The second value is always the y coordinates. So the solution is the x and the y coordinates of this point. This point is the solution of the system. Okay, number 5. Number 5. I'm going to graph the first one. 6x plus 3y equal to 12. I'm going to figure out the x-intercept. So 6x, get rid of the y term because y equal to 0. So 6 times x equal to 12. So divide both sides by 6. So x equal to 2. So 6 times 2. 6 times 2 equal to 12. So x equal to 2. X equal to 2 is right here, this point, right? This point. Okay, now the y-intercept. Get rid of the x term, so 3y equal to positive 3y equal to 12. So 3 times what equal to 12? So 3 times 4. So y equal to 4. 1, 2, 3, 4, right here. Y equal to 4. Yeah? Now I'm connect this 2 point, connect this 2 point, make it a little longer. Make it a little longer, both ends. So this is the graph. Okay, second graph. 8x plus 4y equal to 24. X-intercept. 8x equal to 24. X equal to 3. The y-intercept. 4y equal to 24. Y equal to 6. So x equal to 3. Right here, right? X equal to 3. No, this. X equal to 3. So y equal to 6. 1, 2, 3, 4, 5, 6. Y is right here. Now we're going to connect these 2 points. And make it a little longer. Whoa. Whoa. Look like these 2 lines parallel to each other. So, no solution. They never cross each other, right? Never cross each other. All right. Number 6. Jill babysits and earns $Y at a rate of $8 per hour plus a $5 transportation fee. Okay, Jill. So she earns $Y and the rate is $8 per hour and 8 times the number of hours she works, she babysits, and then plus 5. And then Samantha, she earns $2 and then $16 per hour, so 16x plus $10 transportation fee. We can graph the first one by slope-intercept form, but the second one, we need to simplify the equation by divide every term by 2. We simplify it. So this becomes y equal to 8x plus 5. Oh, then these 2 equations are the same. So 2y, 16, and 10. Oh, they doubled every term, right? Okay, we are going to graph. So this kind of form we call slope-intercept form. The slope is 8, y-intercept is the first point, which is 5. So we start using slope-intercept form. So 5, the 3, 6, 3, 4, 5, 5 right here, right? Close. 5, start from 5, and the slope is 8. Slope is 8, that means from my first point, I go up 8 units, rise up, and then run 1, find my second point. So 5, 6, 7, 8, 9, 10, 11, 12. So from 5 to 5 plus that's 13. So should be here 13. And then run 1. Should look like this, the graph. This graph showed how much money these two people make, right, by babysitter. Because they are the same equation after we simplified. So all we need to do is graph 1. And determine the number of hours each need the babysitter to earn the same amount. They work any hour. So this question is a little bit silly. Yeah. Write a system of equation and a graph to determine the number of hours each need to babysit to earn the same amount of money. No matter how many hours they work, they make the same money. Okay. First page is